These are some of the notations that can be used. For the first derivative, we can use f prime of x, y prime, dy, dx. For the second derivative, we can use f double prime of x, y double prime, d2y, dx squared. For the third derivative, we can use f triple prime of x, y triple prime, d3y, dx cubed. For the fourth derivative, we can use the number 4 but enclose it in parentheses. So this is the fourth derivative of the function with respect to x. And then this is the fourth derivative of y, d for y, dx to the fourth. For the fifth derivative, you can use the 5 but enclose it in parentheses. And then for the sixth derivative, you can use 6 and close also 6 in parentheses and so on. Example number 1. Find the first, second, and third derivatives of f of x is equal to 2x raised to the exponent of 4 plus 7x cubed minus 12x squared plus 6x plus 5. Letter A for the first derivative. Using the power rule for derivatives, we get f prime of x is equal to 8x cubed plus 21x squared minus 24x plus 6. The derivative of 5 being constant is 0. And then for the second derivative, find the derivative of the first derivative. Using the power rule for derivatives, we get f double prime of x is equal to 24x squared plus 42x minus 24. The derivative of 6 being constant is 0. And let us see for the third derivative, find the derivative of the second derivative. Using the power rule for derivatives, we get f triple prime of x is equal to 48x plus 42. Example number 2. Find the first, second, and third derivatives of y is equal to 4 sine of x plus the quantity x minus 3 raised to the exponent of negative 2 plus 5x for the first derivative. We learned in one video in this channel that the derivative of sine x with respect to x is equal to cosine x. So this is equal to y prime is equal to 4 cosine of x. And then using the power rule, we get negative 2 times the quantity x minus 3 raised to negative 3 plus 5. This can be written as negative 2 times the quantity x minus 3 raised to the exponent of negative 3 plus 5 plus 4 cosine of x. And we can make this exponent positive by bringing this down the line of division. So we get negative 2 over the quantity x minus 3 raised to 3 plus 5 plus 4 cosine of x. Let's now solve for the second derivative. The second derivative is the derivative of the first derivative. In letter A, we got the first derivative, y prime is equal to negative 2 times the quantity x minus 3 raised to negative 3 plus 5 plus 4 cosine of x. Now, using the power rule for derivatives, we have y double prime is equal to 6 because negative 2 times negative 3 is 6 times the quantity x minus 3 raised to negative 4. This is the negative 3, negative 1. It's negative 4. The derivative of a constant is 0, so the derivative of 5 is 0. And then, in one of the videos in this channel, we learned that the derivative of cosine x with respect to x is equal to negative sine x. So, this is equal to negative 4 sine of x. Let us make this the exponent positive. So, this is the equal to 6 over the quantity x minus 3 raised to the exponent of 4 minus 4 sine of x. Let us now solve for the third derivative. The third derivative is the derivative of the second derivative. In letter B, we got the second derivative y double prime is equal to 6 times the quantity x minus 3 raised to negative 4 minus 4 sine of x. Using the power rule for derivatives, we get y triple prime is equal to negative 24 because 6 times negative 4 is negative 24 times the quantity x minus 3 raised to negative 5. Negative 5 because negative 4, negative 1 is negative 5. And then, we learned in one of the videos in this channel that the derivative of sine x with respect to x is equal to cosine x. So, this is now equal to negative 4 cosine of x. Let us make this exponent negative 5 positive. So, this is now equal to negative 24 over the quantity x minus 3 raised to the exponent of 5 minus 4 cosine of x.